Today we're going to talk about the Michelson Morley experiment because last night I was watching some videos on the Michelson Morley experiment and I discovered a logical flaw in the logic of the experiment itself. Now, the purpose of the Michelson Morley experiment was to prove the existence of the ether, to prove the existence of a medium for the propagation of light. Okay, so what I'm going to show you today is that there was a logical flaw in the assumptions that they were making regarding the Michelson Morley experiment and the interpretation of the results. So here is one of the videos that I watched called Special Relativity in the Michelson Morley experiment, and this is the experimental setup. So I will just play the video and you can listen to how this setup all works.
We'll need a setup something like this. For this we'll need a light source, two fully reflective mirrors, a half reflective mirror. A half reflective mirror only reflects half of the light, the other half passes straight through it. We'll also need a detector which will detect the amount of light incident on it. The light source is placed at the bottom center of our setup. The half reflective mirror is placed at the center at a 45 degrees angle to the direction of light emitted from the source. The two reflective mirrors are placed at the right and at the top of our setup, making a 90-degree angle at the center. The mirrors are placed at exactly the same distance from the center. Let's emit a beam of light from the source. It will hit the half reflective mirror which is placed at 45 degrees angle at the center of our setup. Half of the light passes through this mirror and the other half gets reflected. The two mirrors, which are precisely at the same distance from the center mirror, reflect back the light towards the center again. Here they combine as they head to the detector. Now, the point to note is, as the mirrors are placed exactly at the same distance, the light reflected from them will reach back at the exact same instant of time, and both.
Okay, so that is the experimental setup. It is set up in such a way that when light is emitted from the light source, it goes through the half reflected mirror. Some of the light goes this way, some of the light goes this way. They meet back here and end up, the light ends up at the detector over here, and they arrive at the same time. And so because they arrive at the same time, the waves are in phase with each other, and so you are not going to get an interference pattern. And so then they go on, this video goes on to talk about waves and wave interference patterns and additive and subtractive waves. And so the assumption here is that if there is a medium for the propagation of light, that it should behave in a certain way. And this is where I believe their assumptions were wrong.
Now let's go back to our experiment. Let's assume the direction of the ether is horizontally to the left. The horizontal wave will get a boost while going.
Okay, before I continue, I want to explain to you what this assumption was. So the assumption they made was if the Earth is traveling through a static ether, it is going to experience an ether wind, not unlike what you would experience if you were in a convertible car and you're driving, speeding down the road and you feel the wind in your face. And so their assumption is that if the Earth is going through a static ether, that is going to experience this ether wind, and this is equivalent to as if the Earth was sitting still and the ether wind
going towards the mirror due to the ether flow in the same direction.
Okay, and this is where I believe they made an incorrect assumption. But just to make sure that this is in fact the assumption, I asked ChatGPT. Okay, so let me just expand this a little bit. Okay, my question was, why does the Michelson Morley experiment assume there is an ether wind? Okay, so then it says the Michelson Morley experiment conducted in 1987 by Michelson and Morley aimed to detect the presence of an ether wind, which was a theoretical concept at the time. The experiment was designed to test the prevailing scientific view that light waves required a medium called the luminiferous ether, or the ether, to propagate through. Seems like a reasonable assumption, and this is not the assumption that I think is wrong. Okay, the ether was envisioned to be an invisible, all-pervading substance that filled the entire universe. It was thought to be a stationary, absolute frame of reference through which light waves would travel, similar to how sound waves travel through air. The idea was that the Earth's motion through this ether should produce an ether wind, just as a moving object produces a wind when moving through a stationary medium like air. Okay, so this is where the logical problem comes in, because if I am in a convertible and I'm driving down the road, it feels like there is a wind, but I am not producing wind. Okay, the wind is not blowing. So on a beautiful sunny day, on a very still day, the wind is not blowing. And me driving my convertible, I don't have a convertible, but if I had one, it would be really fun to drive down the road and feel the sensation of what feels like a wind in my face, even though the wind is not blowing. And so this is where I think the logical problem comes in, because what I'm claiming is that the earth moving through the ether, the wind that you feel, that the earth feels moving through the ether, is not equivalent to the earth sitting still and the wind blowing. Okay, those two conditions are going to produce drastically different effects. Okay, so let's go back to the video.
Now let's go back to our experiment. Let's assume the direction of the ether is horizontally to the left.
Okay, so here they are assuming that the experiment moving through the ether is equivalent to the ether moving through the experiment. And so here they're showing the ether moving from right to left.
Horizontal wave will get a boost while going towards the mirror due to the ether flow in the same direction, but will face a resistance while coming back traveling against the ether. Overall, it will take longer than the vertical wave, which faces no resistance but will get deflected towards the direction of the ether.
Okay, so basically what they're showing here is that they're assuming that the ether wind is going to, so when the light is emitted from the emitter, which is down here below the frame that's being recorded here, so the light comes in, it goes through this half mirror, and their assumption here is that the wind is going to blow it. Okay, I'm going to turn the sound off and just show you the picture. So the wind is going to blow the light. The light is going to follow this path, which is a slightly longer path than it would be if the wind wasn't blowing and it was just going straight. Okay, so this seems strange to me, but if the wind was blowing, if the ether wind was blowing, or if this was air and this was sound, the wind blowing this way, of course, would affect the molecules in the medium, and the sound wave would definitely be affected by the wind blowing. So let's forget about that experiment for a minute, and let's go to an experiment that we can do, a thought experiment in our head, using something that we are more familiar with, which is the sound going through the air. Okay, and so the ether wind analogy of a vehicle going through the air, creating a wind, okay, is analogous to the ether wind that the earth would experience if there was an ether and we were going through the ether, and what we would experience. And so my claim is that driving through the air, the ether wind that we experience is not the same as if the wind was blowing and the car was standing still. Okay, so here on the left we have a car, a convertible. Of course, I didn't have time to make pretty slides, so we just have to use our imagination. This is a thought experiment, and in thought experiments, you're supposed to use your imagination. And so here is a car. It is a convertible. You can assume it's a convertible, and I'm just going to actually put a couple of people. I'm going to put a person in the car, and I'm going to put a person in the car here. So this is kind of a funny car because the steering wheel's in the middle, but whatever. So we've got a car with a person in the car, and we have a person over here. This is my schematic for a car, a person in the car, and a person not in the car. And so here, this is a top view. This is a side view. Okay, I'm actually going to, let me see, I'm going to connect these two guys. So I'm going to group them. Okay, this will work out better. Okay, so we've got the car, and the car can move. Okay, the car can move, but the person in the car is moving with the car, and the person on the right, of course, is not moving with the car. So in your imagination, I would like you to imagine that the person in the car has a very heavy object in their hand. Okay. Okay, what I'm going to do here is I'm going to move this guy here in the middle so that he's in line with this guy here. Okay, so this person is in the car. The car is moving. The car can move. Okay, and so I want you to imagine in your mind now, if this person in the car is not moving. Okay, the car is not moving. The person is not moving. This is a side view. This is a top view. Okay, so imagine that this person has a heavy object in their hand, like, I don't know, I'm going to say a bowling ball. Bowling balls are kind of big, but just a very heavy chunk of uranium or something. You know, that wouldn't be very good either. A chunk of metal in their hand, and they throw it up in the air and they catch it. Okay, they throw it up in the air and they catch it. What is this person going to see? This person is going to see the ball going up in the air and the guy catching it. So it is going to see the ball going up in front of it, in front of this guy. Okay, it's going to see the ball going up, and it's going to see the ball going down, or the object, whatever it is, and that's what it's going to look like to the observer that's not in the car. Now, what we're going to do is we're going to have the car move. Okay, we're going to have the car moving really fast down the road so that the person in the car is feeling the ether wind. It's a convertible, so they feel the wind. Okay, and so the car is moving, and when the car gets exactly to this point, the person throws the object up and down. Okay, but it's still moving. The object is very heavy, so the object has inertia because the car is moving. The object also has inertia. Okay, so at this point, the person is going to throw the object up and down, and what this person is going to see is they're going to see the object go up and to the right because the car is moving into the page. So here is a side view. The car is moving into the page, and this person over here is going to see the object go up and to the right and go down and to the right because the object has obtained the inertia of the car. Okay, so it has got the inertia because it has mass. It's got inertia. So because the car was moving, the object obtained the inertia, the velocity of the car, and so it is going to have that. And so now I want you to imagine, instead of a very heavy object, I want you to imagine that this guy now has a ping pong ball. Okay, the guy has a ping pong ball, which is very inertialess. Okay, it has a little bit of inertia, but not very much. It's almost inertialess. You can imagine that it is exactly inertialess. Okay, so when the car is sitting still, the person throws the object, the ping pong ball up, and then catches it, and that's exactly what this person over here sees. The person sees the ping pong ball go up and down in the same spot, and all is good. Now what I want you to do is imagine that the wind is blowing from the top to bottom. Okay, so the wind is blowing in this guy's face. Okay, the wind is blowing towards the person that's sitting in this car. Okay, now this person is going to throw the ping pong ball up, and what's going to happen is the wind is going to catch the ping pong ball, and the ping pong ball is going to fly backwards. Okay, so because the ping pong ball doesn't have a lot of inertia. Now, if this was the heavy object, the wind probably wouldn't be able to blow it. So if the wind was blowing and he or she threw the heavy object up, that person would probably catch that object, and this person would see the object go up and down in place. Okay, so it wouldn't be moving in any direction. But if it was a ping pong ball, this person is going to throw the ball up. The wind is going to catch it. The ball is going to go backwards this way. This guy is going to see the ball go back this way, and this guy is going to see the ball go back this way. Okay, because the wind is going to blow it, because it has surface area, it's going to blow it back this way. Okay, so now I want you to imagine that there's no wind. There's no wind. The car is moving down the street, and when it gets to it's moving very quickly down the street. So it feels the wind. It feels the wind. The person feels the wind. The ping pong ball feels the wind as it's moving. Okay, but the wind is not blowing. In this experiment, the wind is not blowing. Okay, the car is moving very quickly, but the wind is not blowing. But this guy thinks the wind is blowing. It feels like the wind is blowing, but the wind is not blowing. So when the car gets exactly to this point, the person throws the ping pong ball up. What is this guy going to see? 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 Okay, so what this guy is going to see is the ping pong ball is going to look to him as if the wind blew it backwards. Okay, it's going to this guy is going to think the wind blew the ping pong ball backwards. But what this guy is going to see on the right, this guy is going to see the ping pong ball was released exactly at this point that the first experiment was done. So the ping pong ball goes up. As soon as the guy lets go of the ping pong ball, it is no longer experiencing the wind. Okay, because it's almost completely inertialess. Okay, it is no longer experiencing the wind. The wind is not blowing it. Okay, so what this guy is going to see is the ping pong ball go up and down as if the car was sitting still. Okay, so almost exactly, because the ping pong balls have a tiny bit of inertia, he's going to see it maybe tiny bit obtain the inertia of the moving vehicle. But for all intents and purposes, if the ping pong ball was completely inertialess, if it was made of a substance called inertia, okay, let's call it inertia or inertium. Actually, Robert Distinti invented a term called inertium. So the ping pong ball is made of inertium, which has zero inertia. So when this guy throws the ping pong ball up, okay, as soon as he lets go of the ping pong ball, the ping pong ball is no longer experiencing the wind because it's not windy out. There's no wind. And so this guy sees the ping pong ball go up and down, the same or similar to what he or she saw when the car was sitting still. And this is what I believe is the logical flaw that they made with the Michelson Morley experiment, because when the wind was blowing, they both saw the ball go backwards. Okay, but when the wind isn't blowing, when the car is moving and it's experiencing the wind, only this guy experiences the ball going behind him or her. Okay, so that is the revelation I had last night while watching the Michelson Morley experiment. And so let's go back to the experiment and I will explain to you what I think the problem is with the Michelson Morley experiment. Okay, so let's go back to this slide here. So in this slide here, they were assuming that the ether wind was blowing, okay, the ether wind was blowing from right to left, and that the ether wind was is pushing the signal in such a way that the path length from here to here is now longer than it would have been if it had just gone straight up this line here, okay, because of, you know, Pythagorean theorem. This, you know, basically this length would be longer than this length because this is a triangle. And so so when the Earth is traveling through the ether, okay, is equivalent to this experiment moving from left to right. So instead of thinking that the wind is blowing, okay, we want to think that the experiment is moving through the static ether. So now these lines are static ether. Okay, so in your mind, think of the ping pong ball. Okay, this is the convertible, and the light is the ping pong ball, but light, of course, is completely inertialess because it has no mass whatsoever. And so what is going to happen? As soon as the light source lets go of the light, as soon as the light is no longer attached to the moving vehicle, okay, it is going to go in a straight line. It is going to go in a straight line, and what's going to happen is the vehicle is going to move from left to right. So the light is going to go in a straight line, but the vehicle is going to be, the light is going to hit this part of the mirror, because this part of the mirror is going to be over here now because the vehicle is moving. So the light is not taking a longer path. What's happening is the vehicle is moving from left to right, the light is taking a straight path, and the vehicle, the experiment, is moving. Okay, so the light is going at the speed of light because there's a medium for the propagation of light, and the medium for the propagation of light, the speed of propagation in the medium is the speed of light, no matter how this vehicle is moving. So in the convertible experiment, the speed of sound is the speed of, if the wind isn't blowing, the speed of sound is the speed of sound is the speed of sound, no matter what the convertible is doing and no matter what the guy on the side of the road is doing, okay? And so as soon as the experiment lets go, as soon as the light source lets go of, as soon as the light source is no longer attached to the vehicle, it is going to go in a straight line, and the vehicle is going to move such that it's going to hit this part of the mirror instead of this part of the mirror, and then it is going to bounce back, but then the vehicle has moved further, and so it is going to hit this part of the mirror instead of this part of the mirror, and but the path that it takes is going to be the same as if the vehicle was sitting still. Okay, it's just going to hit the mirrors in different spots, and that may create some effects. Now in this one, the mirror is parallel, so it is going to hit the mirror. Instead of hitting the mirror here, it's going to hit the mirror here, and the mirror is going to move over to the right, so it's going to hit the mirror and it's going to come back. So the path it takes is not going to be different. Now it is going to intersect this mirror a little bit differently, but the path it takes is going to be the same. The path it takes from here to over here is going to be the same as if the experiment was sitting still. And the same with this. Okay, so the light is emitted here, it goes this way and hits this mirror, but the experiment is moving from left to right, and so it is going to hit this mirror, because this mirror is going to be over here now. It's going to hit it a little sooner, but it's going to reflect back, and then because the experiment is moving from left to right, it's going to hit this one a little later, and because this is going at constant velocity, those two differences are going to average out, and this is going to take the same path that it took when the experiment was standing still. So this one is going to take the same path. It's going to, the path distance is going to be the same, as if the experiment was sitting still, this light here is going to take the same path. Okay, it's going to go up and it's going to go down, but the experiment is moving. Okay, this is analogous to when the ping pong ball, when they throw the ping pong ball up and the vehicle is moving, the ping pong ball goes up and down. It does not move with the vehicle because it's practically inertialess. You have to assume it's inertialess for this thought experiment. It is not going to continue moving with the vehicle, and the light is not going to continue moving. It's not going to move in a different direction because the wind is not blowing. Okay, when you throw the ping pong ball up, as soon as you let go of the ping pong ball, it is no longer experiencing the wind of the car going through the air, and it is going to go up and down. Okay, it's going to go in a straight path, the same path that it took before. There is not going to be any difference, and that is why we don't see a fringe effect, because the ether wind that we experience, that the Earth would experience going through a static ether, is not the same as if the ether is blowing. Okay, it's not the same as the Earth sitting still and the ether is blowing. I think I proved that with my little thought experiment, but this is the logical flaw. The Michelson Morley experiment absolutely does not prove that the ether doesn't exist. Okay, it absolutely does not prove that the ether doesn't exist. So here is a paper I found called Acoustic Michelson Morley Experiment with an Ultrasonic Rangefinder. Okay, and so here they do an experiment in the air. They do a Michelson Morley-like experiment in the air, and they discover that they also reproduce the relatively null result. So the null result just means that they didn't see any ether wind. Okay, so an ultrasonic rangefinder was mounted on a horizontally rotatable rail at a fixed distance to a reflector to the top of a car. So they used a car. I'm not going to get into this. I will leave a link to this in the description. But basically, they reproduced a Michelson Morley-like experiment, and they were able to reproduce the results of the Michelson Morley experiment. And so, of course, air has a medium, air is a medium, and so if you can reproduce the Michelson Morley results using a ponderable medium like the air, then you can safely say that the Michelson Morley experiment does not prove that the ether doesn't exist. So I hope this makes sense. I hope I did this justice, and maybe at some point I will make a better video with better graphics and animations and that sort of thing. But this kept me awake all night, and I had to get up and make this video ASAP, because otherwise it was going to bother me all day. And so I'm going to leave it at that, and hopefully you get what I'm saying and do the thought experiments yourself. Maybe even do the experiments yourself, and you will see what I see, in that the assumption that the Earth going through the medium creating ether wind is equivalent to the Earth sitting still and the wind blowing. They are not equivalent, and they cannot be compared. Okay, so have a good day, and I'll be back.